Okay, so the 5.4 second derivative test, we would use the second derivative test to locate the local maximum and minimum. And local maximum versus global, remember we talked about that a few lessons ago? So local max and min is just the one within the area that you're looking at, which is usually what we're working with anyways. So if we take a look at this graph that's on the left here, I've just listed the properties below it. So this is stuff that we've been doing, but this is the first time you're seeing it all put together. So if we take the first derivative at that point C, we know that it would be equal to 0 because it's like we're going across like this, right? So that's the first thing. At that point, because of the shape that it's taking, we know the second derivative would be greater than 0. And that we call concave up, which means that it would have a minimum. So you see what I mean? That it is review. It's a bunch of stuff we've done, but now you're getting to see it all put together. And then if we go to this one on the right, it's all the same stuff, but referring to a maximum this time. So first derivative is still equal to 0 because of the fact that we're basically looking at a tangent that would go like that. The second derivative this time is less than 0. It's concave down, so properties we know, and we know that that means that it's a maximum. The second derivative test, if you take the second derivative and it ends up being equal to 0, the test is not informative. This kind of makes sense if we compare, I guess, this part and this part, because look at what we used to decide if it's concave up or down. We used whether the second derivative was positive or negative. So if it's just equal to 0, then we don't really know. It's not telling us that information, and we'd have to do some more work to figure out what's going on. So if we take this and actually practice and apply what this is referring to, let's take a look at an actual function that we can apply it to. It says find any local extrema. I just put it in brackets so you know what that is. That's just another word for max or min, or maximum or minimum, using the second derivative test. So basically, to put this into perspective so you can view it from a perspective of connection and not see it as a bunch of separate stuff, this one question is basically going to summarize all the stuff we've done so far. So let's go through it step by step. Step number 1, we want to find the critical numbers. We want to do that by first finding the first derivative. I'll say this, I've been saying it the last few days, I've chosen one that's pretty straightforward so we can focus on the concepts, but you know that I could give you a function that's rational and you might have to use the quotient rule, you might have the product rule, all sorts of things. But in this case, we know that this would just be 3x squared when I take the derivative of that one, minus 12 when I take the derivative of that one, and the plus 5 is a constant, so we know that it would just be a 0. And then, if we take a look at this, you notice that we can actually factor out the 3. So we'd be left with x squared minus 4. And then I could actually take it a step further and say x plus 2, x minus 2, because we recognize that this is actually a difference of squares. Right? So once you do that, if we're looking for the critical numbers, remember we always take the first derivative and then we set it equal to 0. When I set it equal to 0, that 3 would be gone, right? So when we solve or isolate this, I know that my x would be plus or minus 2 when I get them equal to 0 separately and I isolate and do all that work. So there's the first step. And then here's the second step. Is it weird that the teacher waves to people walking by in the hallway? The second step is finding the second derivative. So I'm going to take what we have here and we'll now take the second derivative of this. And we can see from this that we would get 6x, and we know that this minus 12 is a constant, so again it leaves us with nothing there. Okay, so then, since, maybe I should do it back here. I'll go back to here for just a second. F prime of 2, because remember how we had these critical values? If I were to plug in f prime of 2, I would get that it's equal to 0. And if I were to plug in f prime of negative 2, I would get that it's equal to, sorry, that's not what I want. If I now take the second derivative down here, so if I take f double prime of 2, I get that it's equal to 12, which is greater than 0. So that tells me it's concave up because of this being greater than 0. That's always what we've been using as our principle to decide. It's concave up. If it's concave up, is that a max or a min? That's a min. Does that make sense to everybody? I'll put it in brackets there. So this is basically the information we're using to sort of guide us and to figure out what is going on. Let's do the same thing, but maybe using the minus 2 this time. So if I were to do f prime of minus 2, we know that that's equal to 0. That's like, it makes sense. That's how we got to this in the first place. So then if we do that down here, if we want the second derivative and we're dealing with minus 2 here, we would get negative 12. Because we're plugging it into here, right? And when we get negative 12, it's less than 0. So we know that it's concave down, which would mean that it's a maximum. Make sense so far? Going back, because I realize after you go through and do all this work and do all the steps, so we took the first derivative, we set it equal to 0, we solved to find the critical values, then we took the second derivative, and we worked our way through that. It says find any local extrema, so we did that. We found it here. Good? Maybe the only other thing, and I'll do it just, I'm going to squeeze it in off to the side here, is to actually give our answer. Maybe I'll carry on up here. If I had f of negative 2, because that was one of the critical values I was working with, I would take that and plug it back into the original equation, because if I'm looking for the max and the min, I want the actual point. I want the coordinates. Does that make sense? So I want to know what the y value is there. I plug it back into the original equation and I'd get 21. So one of my answers would be negative 2, 21, and that would be where my maximum occurs. I would do the same thing with f of 2. So I'd have f of 2. I'd plug it back into my original equation right here. And when I do that, I get negative 11. So my point 2, negative 11 would be my minimum. So technically, this is the actual answer after going through all of the work. Questions? Do you feel like it actually is a review and summary of stuff we've done? Good to have though, maybe that repetition. Okay, so then let's take a look at one more that looks slightly different, just so we get to practice some different strategies. So, just thought it'd be good to get some variety with this. So if we have this function this time, f of x equals 6 over x squared plus 3, you don't have to do it this way, but I find oftentimes it makes it easier if we change this to x squared plus 3 to the power of negative 1. So you don't have to. You could have done the quotient rule and worked your way through it that way. But by setting it up this way, I think it makes it a little bit easier for us to work with it. And then we can work our way through it as we normally would. When I go to take the derivative of this, I feel like consistently quite a few people mix things up with the product rule and the chain rule and the combination and when you do what. So I'm going to go through this step by step. That's why I've chosen this, so that we can sort of work our way through that, because it wasn't just one or two people, it was several. So do you see that we would bring this down to do the power rule? So I'd have minus 6. I'd still have x squared plus 3. At the top, remember, we always take away 1, so I'd have minus 2. But then I also need to multiply it by the derivative of the inside. So I need to do the chain rule with this as well. So I would also have that times 2x. I feel like most people were fine with that, and this was all good. It's when we got to the next step that we ran into some problems. So I'll go through that step by step as well. Are we good with this so far? Changing it to the power of -1, working our way through it this way. And this is personal preference. Maybe you didn't find that easier. That's not how you have to do it. You take your pick of whatever you find easiest to work with. This is one strategy we could use. It will be nice, though, to simplify this and clean it up a little bit so it makes it easier for us to work with. So we can see that this and this can be combined. Well, I don't know what's going on with that equal sign. Let's fix that. Minus 12x. And then here we have x squared plus 3 to the minus 2. Here's where things went downhill this morning. The color coding went downhill. So I'm going to try really hard to do it right this time. So that we're going to call f. That we're going to call g. You don't have to, but I really find oftentimes the biggest issue with this stuff is organization. So I'll just remind you that if we want the second derivative of this thing, what we would have to do is we would have to do f times g prime plus, do you see why the colors are so... Like, it's really not that hard, but I'm having a hard time for some reason. Anyways, I think I got it. So this is the, I would say maybe get into the habit of writing that if it helps you, just to get some clarity, because I saw like little mistakes that I feel were unnecessary. And I think little organizational tweaks will help to eliminate that. So that's what we want to do. So let's work our way through this using that as a guide. So if I want f, I'm just going to take this negative 12x from up here. And then for my g prime, well, do you see that my g prime would be, I did the opposite order, but anyways, g prime would be -2 times x squared plus 3 all to the power of -3, but then I also need to multiply it by 2x. Do we get that? Again, this was the one where a lot of people struggled. So please ask if you are not sure where any part of that came from. Are we good with that? Yes. The 2x is because... See, like what color do I use? This is crazy. In here, do you see after we've taken the derivative of the big thing, the big brackets, we have to do the chain rule and take the derivative of what's inside to get that? So it's from the x squared in here. That becomes 2x. Good? Anything else that's unclear, like where it came from? Okay, you see what I mean with the organizational stuff? That's the hardest part. So then we have plus, and we're going to do the same thing on the other side, except we want f prime. So if my f was -12x, it's just going to be -12 for my f prime. So that takes care of that part. And then I want just multiplied by g. And g is this big thing over here. So it's going to be times x squared plus 3 all to the negative 2. Whoa. Are we good with that so far? It's pure organization. Do you see that? Are you believing me? Because this has the potential to look insane, but if you keep things organized, hopefully you'll find it's not too bad. Let's clean things up. Do you see that I can take this, this, and multiply them together to clean things up a little bit? When I do that, I get 48x squared. And I don't know, this just helps me to keep things organized. Maybe these are good habits you could also get into. And we still have this x squared plus 3 to the minus 3 over here. Actually, sorry everybody, I'm going to move it downstairs. Let's do x squared plus 3 to the power of 3. Are we all okay with that? I just thought in one step we could do that and make the exponent positive. And then for the other one, I guess it's the same type of thing, but it would be minus 12 all over x squared plus 3, and the whole thing would be to the power of 2. Are there any questions so far? Okay. Do you see that they almost look the same, the denominators? Except this one, like this one, is to the power of 2, and this one is to the power of 3. So I can just multiply by another x squared plus 3, top and bottom, to make them the same, in an attempt to start to shrink things down. And yes, I do always want you to do that. I want you to get it to one common denominator and to reduce as much as possible. So don't ever hand your answer in like this. Take the next few steps to simplify it as much as you can. So, do you see that working our way through this, we would have 48x squared from there. I'm just going to put it all over. Do you see at the bottom we would end up with x squared plus 3 to the power of 3? And that's why we did all of this. But over here we would have minus 12x squared, and then we'd have minus 36. So then to clean things up, I can just combine those like terms. I get 36x squared minus 36 all over x squared plus 3, all cubed. I just realized my problem with the lesson this morning. I didn't give myself enough room, and I think a lot of you do this as well on your quizzes and tests. And that's where the mistakes sometimes happen. I mean, I'm going to keep going, but for next time I know. So, do you see that we can factor out a 36 at the top here? We pull out a 36. Do you see inside I'd be left with x squared minus 1, which is the same thing as x plus 1, x minus 1 when we factor it? Are we all good with me skipping those steps and doing that? So I factored out the 36 here. And when I did that, I was left with x squared minus 1, which I then simplified to this. So, going sideways because I'm running out of room, do you see that if I were to set this equal to 0, I would get that x is equal to plus and minus 1? From here, like if I set it equal to 0, the bottom would cancel and the 36 would cancel. So the numbers I'm interested in are x equals plus or minus 1. If I am using this to try to figure out, what did it say? Find the intervals where it's concave up or concave down. So now that I know that on a number line, I would be interested in, let's say, minus 1 and positive 1, I want to test like this region here. Oops, I didn't mean to do that. This region here, and this region here. So it doesn't matter which number, but basically we just want to pick some numbers in those regions, and we want to plug them into the second derivative. to figure out if the answer is positive or negative to see if it's concave up or concave down. Does that make sense? So the same old pattern of what we've been doing, but this time we're looking at these three different regions as we do that. So if we were to check, let's say -2, we would plug it into our equation here and check to see what we get. I'm going to assume that you all know how to plug things back in, and I'm just going to end things off here and tell you we would get positive here. In this second region here, do you see that 0 is probably a good one to pick? And it's your choice. You can pick whatever you want, but why not use easy numbers? And we would get a negative there. And in this last region over here, we could plug in, let's say, the number 2, and we find that the answer ends up being positive. The second derivative ends up being positive. So when the second derivative is positive, tell me, is that concave up or concave down? When the second derivative is positive. Good to review and to repeat it. Do you remember? Concave up. Everybody good with that? The second one, if it's negative, if the second derivative is negative when you plug it in, it's concave down like this. And then the third region, again, it's concave up like this. And that's the reason why we did this. We just wanted to know the intervals where it's concave up or concave down. So do you see that I could say that it's concave up? So concave up when x is less than -1. Here I could say when x is, concave down when x is greater than -1 but less than 1. And here it's concave up when x is greater than 1. You don't have to go through every single little step and write it all down. I'm doing that in the notes so that you can see clearly where it's coming from. But you get the idea. We want the first derivative, the second derivative, find the critical values, test the points on either side, and use that to help determine what is going on. Your work is page 232, number 1 to 3.